Okay, it's September 12, 2023. This is Professor David J. De Los Reyes. Okay, my session for tonight will be college algebra. This is a long video format discussion. College algebra, and this will now be lesson number 60. So we are almost done with college algebra. So for those of you who are following my channel on the subject matter college algebra, we are almost done. I will be adding some more, what you call this, additional topics, which has relevance in the study of engineering. Okay, let's proceed. My topic for tonight will be college algebra, and this will now be lesson number 60. We are running smooth, and the title of the topic for tonight will be variations. What are variations? Variations are change or difference in what they call this condition. There are problems on the what they call this not only SAT or CET, because I've been teaching higher mathematics in the formulation of the equation of the so-called differential equation. Uh, we need a knowledge on the so-called study of variation. And this variation is actually the subject matter for tonight. Because without knowing variation, uh, you cannot formulate your equation and how to bring out your differential equation and supposed to be your algebraic equation. Okay, let's proceed. There are three types of variations under the study of algebra. Number one is the so-called direct variation. Have you heard of the thing directly proportional? When we say directly proportional, that is actually direct variation. Okay, direct variation meaning when the other variable increases, the other variable will also increase. That is the so-called direct variation. They are directly proportional. When the other goes up, whether we like it or not, okay, the other one should also go up. When the other one goes down, the other one will also go down. That's its direct variation. To bring out the equation for a direct variation or for direct proportional problems, we term it direct variation or directly proportional. Let's consider for the meantime two variables y and x. So we will be having, or we will be formulating an equation involving y and x if the relation to each other is directly proportional, or meaning direct variation. The change in the other one will make the other one change also. So if the other one goes up, the other one will also goes up. It follows, right? So that is actually direct variation. If we try to bring out the relation supposed to be, it is written like this: y, alpha symbol. This is a Greek letter alpha. Greek letter alpha is designated as the designation for proportional. Okay, so the Greek letter alpha is actually sign of proportionality. Okay, so if under case number one or type number one, we are talking of direct variation or proportional variation. Okay, we can say that y is directly proportional to x. Okay, no equation yet. Okay, the next step is to put an equality sign. So if you try to put an equality sign, there will come out an equation, and that equation is actually the equation for a direct variation. So if we see y varies directly with x, I will now be formulating the equation y is directly proportional to x. So this expression here, if we try to put it in terms of an equation, it is like this. Y varies directly with x, okay? I will write it in another form, y varies directly with x. Then if I will now try to bring out the equation, okay, I will put an equality sign, but I will be introducing a constant k. And that constant k is actually the constant of proportionality. Okay, so y varies directly with x. So y now will be equal to a certain constant k multiplied by x. And this is the required equation for direct variation. Okay? Two variables, it says that they are directly proportional. If we try to bring out the equation, am I still on camera? Y should be equal to kx. If we try to bring out now the legend for this one, x and y are the two variables which we are comparing values, right? And alpha, the Greek letter alpha, is the sign of proportionality. Okay? And this constant k here is a constant of proportionality. So for any given problem, okay, there will be a value k. So it depends on what type of problem, right? Okay, variation number 2. This is the so-called inverse variation. Inverse meaning if the other variable goes up, if they are inversely related, the other one should go down. If the other one should go down, the other one should go up. So actually, the what you call this, they will try to vary themselves separately. Not unlike on the so-called direct variation, that the other one goes up, the other both will go up. But under inverse variation, if the other one goes down, the other one will go up. And if the other one will goes up, the other one will go down. That is termed to as inverse variation. So if I will place it here, y varies inversely with x. Okay, that's an English language, right? If we try to bring out the equivalent of this in terms of an equation, it will be written like this. Y is inversely proportional. This is still a proportionality constant, like in the first one. But under inverse, instead of just simply writing x, because the inverse of x is 1 over x, right? So this should be y is inversely proportional to x. If we try to write it, it will be something like this. It should be 1 over x. Because if it's only x, they are directly proportional, right? But if it's 1 over x, okay, the inverse of x is 1 over x. So y is inversely proportional to x. And if we try to put it in terms of an equation, y now, we replace this constant sign of proportionality by a constant k. But the value of the term on the right hand side, instead of x, okay, for inverse variation, it should be 1 over x. So under inverse variation, okay, y is actually, it can just be simply k over x, or k times 1 over x. It is understood that they will actually change among themselves inversely. Okay, like what I said, if the other one goes up, the other one should go down, and the other one will go down, the other one will go up. Okay, that's inverse variation. Easy, right? Because without knowing these two variation concepts here, when we go to differential equation or advanced math, in the so-called formulation of the differential equation that is needed to solve the problem, okay, there are conditions given by the problem. So sometimes there is a direct variation and there's a inverse variation. It depends on what type of problem we will be solving. Okay? Okay, so at least we now know what is a direct variation and inverse variation. And the third one, this is the more complicated one. Okay? The number 3 type of variation is the so-called joint variation. Joint, meaning we are not only what you call this comparing values one variable to one variable. We might be comparing one variable to another two variables. That's why it is joint, right? So if I will try to put this joint variation in English language, y varies jointly with x and z. So as you can see it, the right hand side is actually in terms of x and z. So when we mean x and z jointly, the proper word for this is jointly. Okay? So if I will now try to convert this English language to or verbal equivalent in terms of an equation, y varies what okay jointly jointly meaning there will be two variables that we are comparing values. So y varies jointly with x in z. And if we now try to replace that alpha, which is sign of proportionality by a constant k, y now should be equal to k times the product xa. If we try to read this, y varies jointly with x and z. Oh, as simple as that one. Okay? So under variation, joint variation, we will be comparing one variable with respect to another variable, and the other variable should have a minimum value too. Okay? So y will now be equal to k times the product of x and z. If I will try to read this, okay, in English language, y is directly proportional to the product of x and z. The varies uh, jointly. Okay, that's it. Those are the three concepts on how to bring out equations for direct variation, inverse variation, and joint variation. Direct is actually the try to go up both at the same time or go down at the same time. For inverse, it's the reverse. If the other one goes up, the other one should go down. Under the joint variation, okay, it will just follow the number one or number two. It depends on what type of condition it will be coming out. But the main thing here is that there will be two variables on the right hand side. That's why the term joint. Okay, so it could be a direct variation or an inverse variation, and they are acting as jointly, right? So y will be equal to a constant k, the product of x. Okay, let's try to bring out an example problem to illustrate the concept of joint variation. I think, I don't know, I haven't encountered this one on the short videos. There are problems which contains variation problems. But for me, since I've been teaching higher mathematics, I encountered most of the time this type of problems involving variations, because in the formulation of the differential equation, we needed this variation concept. Okay, I will try to read the given problem. Hooke's law. Hooke's law is just maybe a physicist, right? A scientist before our time. Because Hooks is actually a family name, so there is the law in what they call this. I think this is under the study of physics. The family name of the scientist inventor is Hooks, so he named his what they call this law into the so-called Hooke's law. Okay, Hooke's law for springs states that the distance of a spring is stretched is proportional to the force on the spring. Okay? A force of 25 pounds stretches a spring with the value 8 inches. So meaning to say, there is a spring, okay, if he applies 25 pounds, that spring could be stretched up to a value 8 inches. The problem is, how far will a force of 75 pounds stretch the given same spring? So meaning to say, if the man or the one performing the experiment is changing the value from 25 to 75, okay, how far will this spring will be stretched? Okay, so if we try to think about the problem, is it under variation? I think it is under variation, because to solve this problem, we must have to bring out a concept on how to formulate our equation. It's always like that. So we are thinking algebra, right? That's why there are people who are termed to as scientists or engineers, because in the formulation of their equations, okay, if they will try to analyze a problem, okay, they will try to bring out a concept in which to bring out the required equation to solve the problem. And for this, I think the problem is under variation. Right? Hooke's law for spring states that the distance of spring stretch is proportional. There is a root word here, proportional. Right? Proportional. So if we try to analyze it, proportional, this should fall under direct variation. One variable is proportional to the other. It is under direct variation. So we are using equation number 1. Right? So if we now try to bring out the solution, okay, board exam style. We brought out the given. We we name what is being asked, bring out the condition, so formulate your equation, then try to solve the problem. Okay, we try to bring out the given. The given thing is, I got the designations over here. I haven't placed it. So there will be a variable f here, and there will be a variable Greek letter delta. Under the study of strength of materials, elongation or stretch is designated by the Greek letter delta. Okay? So I place it here. For condition number 1, I will now be placing some script here. Condition number 1, so if I will place 1 here, meaning it refers to condition number 1 for the given problem. Okay? So F is actually the force needed. This is force. And Greek letter delta is actually elongation or stretch. Okay? So under condition number 1, if the applied force on the spring is 25 pounds, okay, the elongation of the spring, meaning the elongation, from the equilibrium position, if we try to push it down, okay, it will arrive at certain distance. So from the equilibrium position to the new position, that's the so-called elongation. Right? So for condition number 1, if the applied force is 25 pounds, the elongation will be, okay, 8 inches from the equilibrium position. You could stretch the spring if the value is 8 inches. If the applied force is 25 pounds. Condition number 2. Am I still on camera? Condition number 2. If we change the value of the applied force to 75 pounds, how much will be the elongation? Okay? So actually, we have identified already the solution of the problem. Since the problem is under direct variation, and we brought out the condition values, F1, 25, elongation number 1 is 8 inches. Okay, for the requirement of the problem, if the applied force is 75 pounds, what will be elongation number 2? So to solve for elongation number 2, we must solve to bring out a concept to formulate the equation needed. And this falls under direct variation. So if I will now try to place the solution. Okay, I get it here. Greek letter delta is stretch, capital letter F is force. From the, what I call this, verbal analysis, proportional, right? So the elongation designated by Greek letter delta is proportional to the applied force. Okay? We are formulating our equation. So if I will now try to continue, the elongation will be equal to a certain constant k times n. And if we try to solve for k here, okay, we try to solve for k. We divide both sides by f. So it will be the elongation over f. Okay? So if there are two conditions in the problem, you just enclose this one with the subscript 1, and they should be equal to the elongation over force for any condition number 2 in which an unknown is being asked. Okay? So for condition number 1, we are given this one. For condition number 1, we are still given the force. Okay? This is 8 inches, this is 25 pounds. Okay, so for condition number 2, the problem is asking now, if the applied force now is 75 pounds, okay, what will be the elongation? Easy money, okay? We formulated already the equation and how to solve the unknown. So, by using this equation here, okay, actually we have formulated already the solution, the equation and how to solve the unknown by using direct variation concept. So, substituting values using this equation here, delta 1 is actually 8 inches, force number 1 is 25 pounds, and this should be equal to delta 2, the one we are looking for, the new elongation, if the applied force is 75 pounds. So after the substitution, okay, there is only one unknown now. For the meantime, it is not x because we are fan of x. X and y is just a representation in algebra. So when we are having a problem, okay, that unknown could take any form, right? So solving for delta 2, cross multiply, guys. The product of 25 times delta 2, the one we're looking for, the product of this should be equal to the product of this. This should be 8 times 25, or 75 rather, right? And if we are trying to solve for delta 2, the new elongation, we will divide both sides by 25. So left hand side this cancels. What remains on the left hand side will be the required elongation. And for the right hand side, 8 times 75 over 25, this 25 cancel with this will be 3. 8 times 3 will be 24 inches. So the required elongation for a force of 75 pounds is actually 24 inches. That will be answer. As simple as that one. If you know how to formulate your equation coming from the concept or the interpretation of the problem. Because if you interpret this one as an inverse variation, you're wrong. It says it's proportional. Okay? It doesn't say inversely proportional. If it says inversely proportional, our equation is wrong. But it just say proportional. So this falls under direct variation. Okay, that's it, guys. These are just the concepts of variations. An example problem. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes.